So today we are going to see about Newton's law of motion. There are three laws of motion, and the first one states that a body in rest will remain at rest unless a force is applied on it. Then it will begin to move. And it also states that if a body is moving at a constant speed in a straight line, it will keep moving at that same constant speed unless some force is acted or applied on it. So let's see this first law of motion in action. Let's say this is the body at rest and it's not moving, it's at rest. Let's say this finger of mine is going to apply the force. It's at rest and I'm applying the force on this car. It starts to move. The second thing this law states that if this body moves at a constant speed in a straight line, it will keep moving at a constant speed at the same path. But in real world, that is not true, because there are forces acting upon this body, and there are many. Let's assume two of them, two major factors. One of them being friction. When this body moves on this surface, friction is acting upon this body. So it cannot move continuously on the surface. And if this car model were to be a real car and going on a real road, so there is another force acting on it, that is air. The air resistance or the drag created by the air will slow this car down. Now let's move to the second law of motion. The second law of motion states that the force applied on a body is equal to the mass into the acceleration. What does this mean? What does this formula mean? Let's take a different car now. Let's say this is my car. So the second law states that a force applied on the body is equal to mass into acceleration. Now we know that this car is made of metal. Now this car, or Formula 1 vehicle, is made of wood. So metal is heavier than wood. So what does that mean? That means that the mass of this car is more than this. So if I were crash into this car, which is made of metal, using this wooden car, it doesn't do that anything, just moves it a bit. But if I were to switch it up, if I were to crash into this car, which is made of wood, using this car, which is made of metal, it takes it along with it. So here we can see the mass plays an important role. But one more thing in the formula is the acceleration. We know that the mass of this Formula vehicle is less than this car. But what if I increase its acceleration? It moves more now, because the acceleration of this was much higher this time. It was able to exert more force on this vehicle. So if I have a heavy vehicle which is moving at higher speed or greater acceleration, it's going to exert more force on this vehicle. That means force, the amount of force equal the mass of this vehicle into acceleration of this vehicle. Let's just see that here. This is going to come in very, very fast. Oops. Okay, now let's move on to the third law of motion. The third law of motion, which is a favorite law for many people, is very easy. It states that, let's change the card, old school. It states that every action has equal and opposite reaction. What does that mean? Well, it's very simple. If I were to hit this car will move the same amount backwards. That means I'm doing some action with this car. It's having equal and opposite reaction on this car. Let's just see. You do notice that it's not equal, but it is opposite. Why is it not equal? Again, in real world, there are many forces acting on this vehicle too, and this vehicle too. So, there might be some differences, like this vehicle moving more because the mass of this vehicle might be more, or the friction on this, the friction acting on these wheels is less in this wheel, so it's moving more. Can be anything. But the law is basically every action has equal and opposite reaction. I hope you got some idea about Newton's law of motion. If you like the video, please hit a like and subscribe. Thank you.